What we're going to do is continue on from our talk on optimizing, maintaining SQL and SharePoint, but we just do our little bit of intros. We're meant to hold on to that. That's cool.
Can I click again?
Yep.
So this is my job for the afternoon. Okay, I'll just do a brief intro to myself, because I obviously wasn't here in the previous session. Neil Hodgkinson. I'm in the technically SharePoint product group. Sounds a bit glamorous, strictly speaking, Office 365 operations. So look after SharePoint, look after SQL Server in the Office 365 space, both in dedicated and multi-tenant. Like Wayne, MCM, fortunate to have done the 2007 and the 2010 versions of the platform. And basically, SharePoint experience has been, well, since before SharePoint really existed. Yeah. Contact details there, so if you need to speak to me later, feel free to drop me an email, tweet, or my blog is up. It does have a horrible error on the home page. Just ignore that. I'll fix that later.
Yeah. So actually, having done a rotation, I'm actually really impressed that Neil decided to do a second rotation, which is pretty phenomenal. Anyway, my name's Wayne Ewington. I'm from New Zealand. Like I said before, I'm the only one here without the accent. All the sheep are mine. Okay, so if you see any sheep, just send them my way. Take care of those for you. Worked for Microsoft for 11.5 years. Hasn't always been continuous, unfortunately. 4 years ago, I decided to leave for 6 months. And a lot of what my colleagues reminded me was that Microsoft made the mistake twice. Okay? So Microsoft Certified Master, Microsoft Certified Architect, and my email address up there. I've also got a blog, but I haven't blogged for about 15 months, so I don't have a blog.
So you're not current, Wayne?
Not current, not current, yep. Cool. Okay. So what we're going to do is that we've already done the designing and architecting. We're going to continue on and doing the deploying. Then we're going to get into the real nuts and bolts around how you actually go through, maintain and operate SQL Server from a SharePoint perspective. Cool. So just a quick recap. We talked about SQL Aliases. So the only reason for bringing this up is that what we're going to do next is to go in and actually go into the demos and start showing you some stuff around this. So just a quick reminder, SQL Aliases, you're going to do them from now on. Every farm should have them. And we're going to start going through and configuring up some SQL Server mirroring and show you how to do that. So my beautiful assistant, Lana, is going to go through and configure up the content DBs and show you how to do them.
Okay, so having just arrived, I found out that the previous session didn't get around to doing the demo, so they dropped it on me, which was very kind of them.
This is punishment for
yeah,
for
you turn up late,
to
you get to do the demo. So we're basically going to run through a demo. We're going to create a new database. We're going to add a site collection to it. We're going to mirror the database up so it's all mirrored and available. And then going to fail over the mirror and just prove that the whole thing's still online and available. I think that's the demo in a nutshell.
Yep, correct.
So I can get on the right box.
That's SQL 01.
Which is SharePoint. Which one are we working from?
SP3, that'll do.
SP3, okay.
And then Central Admin's already running.
Okay, so everyone's used to seeing Central Admin, or I'm sure you've heard Spence control it.
Actually, you may not recognise this because it hasn't got a red bar on it.
Is that because we disabled the health rules?
Yes.
Okay, so pretty straightforward. First thing we're going to look at is, apologies for leaning forward like this, is to create a new database. Because we want to play around with a brand new database rather than break anything that's already existing that someone else might be dependent on. So we'll keep it nice and simple. Go through the wizard. Obviously, you could do this through PowerShell or however else you decided to do it. We'll call it ISC. It doesn't matter what the name is. What session are we, 103?
Yep, 103.
103.
So it actually should be content ISC underscore.
Okay.
So basically what we're doing here is we're adhering to our naming standards that we kind of alluded to in the previous session.
Okay, sorry.
So ISC, so we always know which farm it's associated with. It's a content type of database, and it's for the intranet.
Since I wasn't here.
Should have intranet before it. No. Lana, go right.
Mm-hmm. Okay, come on. What are we doing? All right, got you. Underscore, intranet.
Yep. Yeah.
No comment about blonde assistants. Okay, we're creating it against the ISC SharePoint 1 SQL alias, which corresponds to SQL 1 in this case. So at this point, I'm not going to configure a failover database server. I'll come back in and do that later. But what I am going to do, just to be sure that my site collection that I'm going to create actually ends up in this database, I'm just going to increase these limits just a little bit above the regular values. And of course, we're not using anything like the default values. So this should give me a couple of seconds to create me a database. Then I'll go ahead and create a site collection. Does site collection have a naming convention?
Yep.
Yes, it does. I can't read that.
Okay.
Okay, so we have our database. Just slide along to the right here. As you can see, it's got limits, warning levels of 5,000, maximum limits of 10,000. So according to the regular rules by where SharePoint creates its new site collections, we should be quite happily now drop a brand new site collection into that database without having to take the other database offline or anything like that. So I'll keep it nice and simple. New site collection, run the right web application. We're going to call it IT Pro 103. IT Pro 103. Straightforward team site, and just...
Okay. So while Neil's typing that in, just something to always be aware about too when you enter in what the username is, particularly if you're using like a test or a development environment. A lot of times you get a little bit shortcut and only put like an administrator. If you don't specify the domain, it will actually default to the local admin. So when you go to the site, you're kind of going, why don't I got access? What's going on? Okay, so as a general rule of thumb, whenever you go into SharePoint, particularly in the central admin, always specify the domain as well. Okay, can save a little bit of aggro.
Yeah, it would be, you would not be surprised how many calls we get for people who don't do that and end up with users from the wrong domain or from local accounts.
Yeah.
So there's our site, nice and created. We'll just go and have a quick look at it. Nice and simple, out the box team site, nothing special. Okay, so we'll just go and check, make sure we know where it is. We'll look under view all site collections. Here's our data site that we created, and we can see that it's created with the ISC London administrator as the primary administrator account, and we can see the database that it was created in. Straightforward. Okay, so now we've created the database, we've created the site collection in the database. The next thing we need to do is actually go and work around with SQL. And in SQL 01.
It's already running.
What's already running?
I've already sorry.
Okay, so we need to go and grab our logs, our script, which is
just sitting on the desktop. Yep. So number one, create the backups.
So pretty straightforward, and this is why Wayne was sensible enough to remind me to make sure I use the right naming convention. Get rid of that.
Okay.
So pretty straightforward. We're going to do our database backup. The first thing we're going to do is make sure that the database is in recovery mode full. Of course, we can't mirror databases unless they're in full mode or full recovery mode. Simple backup to disk, and for both the log file and the data file. This should be nice and quick.
So a lot of the times when I've done a backup, I've never actually done the logs. Why am I having to do the logs as well?
To make sure that we capture every single part of the transaction, including the end of the log file, which is most important to ensure that the database is fully integral or integrated. So the integrity is preserved.
So when I set this up, I've always got to basically do the database as well as the logs and make sure you actually cover both. Okay, otherwise when you're setting up your mirroring, it ain't going to work.
Okay, and we can see our backups here. So I'm going to copy these to SQL 02. Make sure I'm on the right machine, which I'm probably not. Okay, so there's our databases on the E drive of the SQL 02. So I'm going to go back to SQL 01, grab my other script, which is the restore script, and I need to get that out of there. So first mistake of the day, don't stick to the convention.
No, it's because you didn't move the database first. You didn't move the database.
I didn't move it. Okay, my fault. So I'll do this from, well, you could do this technically from come with the locations, but I'll do it from SQL 02. We have, were you on the primary or the secondary?
That was on the secondary. So
sorry, folks. It's kind of it.
my assistant hasn't quite followed the script.
Okay.
Okay, so first of all, what we should have done is actually, we've got two database instances sitting on SQL 01. So what we should have done first is that we looked at the layout and we decided that we actually wanted to move our new content DB to the other instance because we want to change the IO subsystem, etc., associated with it. So that should have been the first step.
Yeah. Okay. So apologies, I didn't move the database. Okay, so we're going to stick with using the SQL 1 and SQL 2 instead of secondary. So the original idea with the demo, like Wayne said, was to move the database, which is a very straightforward operation, simply to detach it from SharePoint, physically move the files, or detach it from SQL, physically move the files and reattach it through SQL and through SharePoint as well. In this case, I'm going to just do the second part of the operation, which is the mirroring piece. I'll do the restore. So we've got our files are here. And we do a straightforward restore. So it's straightforward, nice and in. If we just refresh the databases node here. Yeah, that's right, isn't it?
Yep.
Okay, so we can see our database has arrived, and it's in restoring mode. The reason it's in restoring mode is because we restored it with no recovery, which is basically saying it's sat there now, waiting to receive input. It's in a mode where it can be continually written to.
Yeah. The critical point is actually the no recovery. So when you're setting up your mirroring, you've got to do it with no recovery. If you don't do that, once again, you're setting up your mirroring is not going to work. The other thing too that I've noticed is that if you've take a little bit of time between setting up your backup and doing your restore and actually configuring up your mirroring, if you leave that too much as a delta time, once again, it's not going to work too well. So you've got to try and do it quite quick if you can.
Okay, so having now established that we've backed up the database, we've restored it to the second SQL server. The next thing is a fairly simple operation, hopefully a simple operation, is to configure the mirroring. So nice and straightforward. We're going to use the wizard in this case. It is relatively straightforward to do it through T-SQL queries as well by configuring the failover partner for the databases. In this instance, what I'm going to do is just use the wizard because it's nice and simple.
By the way, it's not a real wizard. It doesn't have a cape.
So choosing the properties, we choose mirroring. We have our principal. And where's the configure security? So we go through the wizard. Basically, we want to configure security to include a witness server instance. In this case, we have a witness server available. You talked about witnesses earlier.
We kind of mentioned along it. So basically, what happens here is that when you've got a witness server, it basically helps form what we call a quorum as to say whether or not you should actually fail over or not. So really the key thing about it is if something happens, what the witness server basically does is that the server goes, can I see the other server? And it goes, no. And then it goes, can I see the witness server? And then if it asks the witness server, can you see the other server or not? And if it can't see it, it goes, oh, the principal's gone down, therefore I need to swap over and take over ownership, become the owner of it. So one of the interesting discussions then is that if you've got, for example, two data centers, okay, whereabouts do you put the witness server? Do you put it on the principal side or do you put it on the witness side? Okay, who thinks it should be on the principal side? Okay, we've got a few people. How many people think it should be on the witness side? Few. How many people don't know? Okay. So the ideal answer, yeah, the ideal answer is that it should actually be in a third data center. But the reality is that you can't often do that. So generally the guideline that we give around this is that the witness should always be able to see the principal. Okay? So the reason behind that is that if the mirror can't see the principal, it will then go check to see whether or not the mirror is actually available, but it then informs the application, but it can say, right, the application actually can see both, so therefore it won't fail over. So that's why it makes sense to keep it on the principal side if you need to do your configuration around it.
Thank you. So I've worked through the as Wayne says, the non-magical wizard. And basically, we configure our principal server instance. We have a listener port defined here. Now, in this particular instance, if I remember correctly, there is already a database that's been configured for mirroring. So it means you can only have one mirroring endpoint configured per SQL Server instance. So we're basically falling back to use the same endpoint that's already configured. Then we have our mirror server instance, and in this case, we're going to host it on SQL 02. That's okay. So again, the listener port is all configured already. Typically, these would be editable if we were able to work around with them. And then the next thing we need to do is, as mentioned already, we need to look for the witness, which, if I remember correctly, is just called SQL Witness. It's the first thing I got right today. And again, listener port, endpoint name. Very straightforward, straight through. Servers accounts, so what we're using?
SQL admin, I think it is.
SQL admin.
SQL admin, IS Cloud London.
So again, as before, specify the domain account, the domain, and we're going to use the same account across all three instances. So there's our summary, so you could capture that so you know what you've actually done. And we click finish, it's nice and sharp. Configures the endpoints on the principal, configures the endpoints on the secondary and on the witness as well. And that is that. That is, in a nutshell, done. We can see our scenario here, and then we can engage mirroring. So we're all being well, this will come back nice and happy.
That wasn't hard, was it? What's the big deal with mirroring?
So we can see already we have our principal synchronized on SQL 01. If I just do this, we can see on SQL, we should be able to see on SQL 02, we have our mirror synchronized and restoring. So that's it as regards configuring the SQL side of mirroring is done. The only thing we need to do now before we can do anything in terms of failover or to ensure we actually have high availability is to go and look at the properties of the database again. And again, we could set this through PowerShell. There's a simple set failover partner option on the database properties. And in this case, we're going to configure the actual failover partner for this database, which is ISC, SharePoint, just two.
Two.
Okay,
Yeah, so what we should be using here is once again the aliases. So what we should also do is quickly just show them the CL config as well. Just make sure they're all running.
So you saw the screenshot, and we have no aliases.
Ooh.
So I'm going to add an alias, since we don't appear to have one. So this is the walkthrough, the demo you weren't going to see. So ISC SharePoint 2.
Yep.
TCP, the endpoint is 1433. It's a standard SQL Server endpoint. If we were using the secondary SQL instance, like we mentioned, like I should have done, we would have had to specify a different port at this point. So ISC SharePoint 2. I should probably fully qualify it, shouldn't I? In fact, I've done that wrong. Excuse me. SQL 02.
So you're going to keep it on dynamic?
Say again?
You're going to keep it on the dynamic port?
Or we can just go to SQL 2 SharePoint London.local. Okay, so it matches the previous one. It's basically the alias to the secondary, to the other SQL instance. You can apply, and OK. And if I wanted to test that, I could just do something like fire up ODBC Connection Manager, just to do a quick test to make sure I can hit that SQL Server. In this case, I'm going to trust in the confidence in my own convictions here and attempt to hit it directly and see what happens. Did we get an error page? Could not connect. Nice. International SharePoint Conference, SharePoint 2. So the demos are blowing up. Good call.
Yep.
Okay.
Yep.
Thank you for the...
So it actually needs to be on all servers.
It does need to be on all servers.
Yeah.
So, do we have IDC now? We've got IDC man on the desktop.
Yeah, no, they're all configured. Just click on clear the desktop.
Okay, cool.
No, it's all password now.
You changed it?
Yeah, back to what it was. Yep.
So you go away for the morning, they do these things to you. Any stories you want to tell? You know any good stories about failed demos?
Well, that's why my demos worked in the first session.
So interestingly enough, it's actually on SQL on SPO2.
Okay.
It's kind of strange. So I'll tell you what I'll do. To avoid any major issues, on SPO2,
So this is what Steve said this morning about us having to stunt demo to try and get this to work, because the next session is dependent on this. So no pressure, Neil.
ISC, SharePoint 2, I'm just going to check it out. No. ISC, SharePoint 2. Go.
Yeah, could be.
Yep. Live troubleshooting.
So how many hours does it take to fly into New Zealand from here? Anybody want to make a guess? So 22. We've got 22 over there.
Yeah. No.
Okay, so as a
I'm
rough rule of
surprised it's not
thumb, it's
there.
about 10, 11 hours to the west coast of America, and then it's usually about 12, 13 down to the southern shores. So a day in a plane. And that excludes waiting time, airport transfers, getting to and from the hotels, etc. So, yeah. So while Neil continues troubleshooting, I once had to attend a one-day meeting in Perth, living in New Zealand. Unfortunately, it was Perth in Scotland. And I kind of started talking to the people and say, do you know where I actually live? And they're going, yes. And I said, I'm quite happy to get up in the early hours of the morning because it's about 12, 13 hours depending on whether or not you're doing daylight saving, time zone difference between New Zealand and the UK. So I said, I'm quite happy to get up, early hours of the morning and, do a teleconference. And they said, no, we want you to be there. I went, this is crazy. So a day on a plane to get to Edinburgh and then drive north to up to Perth. And what was funny was that the people that I met at the Edinburgh airport were complaining having to fly from Southampton. Go figure. So that's the craziest travel story I've ever done.
I thought.
To open up the SP Farm account again, just give it the DB created security admin role. On SQL 2.
See, we asked them to set it up, and what happened?
Can you get Spence in here so I can give him a slap? Yeah, I got an email last night and they told me something different. Okay.
So that's how you troubleshoot. Sorry?
Okay.
Yes? And your point is?
Farm account can use those core permissions to
Yeah, it does.
Yeah, absolutely.
It does. It does.
But telling us one thing. And
Yep.
Thanks. Okay, so thanks, Gary. So that's in place now. The failover partner is there, and I'm now going to fail it over. So I'll just go back to the page
Yeah.
and move on quickly so that we can go to our other demos.
So this is why I got Neil to come on stage so he could actually do the demo.
Okay, so the site's rendering. Nothing's changed.
Sorry, there's a question?
So that section failover server
Is what, sorry?
that's failover server, you guys what is that?
It's just another data. Sorry, it's another. So what we've basically got is that we've got two SQL servers. Okay. So basically, what the issue was is that we've got this other SQL server that we want to put the mirroring on. What we forgot to do was actually to replicate the accounts that are actually on the original server to make sure that they're actually being set up as SQL Server logins on SQL Server 2.
So for each content database, you have to fill in the mirror server as well.
So I'm not quite sure if I
Yeah.
understand, but basically what we need to do is that,
Well, there's a field that says failover server. Does that mean the mirror server?
yes, it does.
Yeah.
Yeah.
Correct.
It's basically the other part, principal and mirror. So it's
Yep.
whichever way around you do it.
Yep. So this is a bit of a change from 2007 to 2010, where 2010 is mirror aware. So basically, as an application, SharePoint knows that there is another mirror sitting down there or a mirror available, so hence it can fail over automatically to it.
You say that you just can't do that with config database.
You can mirror the content DB, and the config DB. You can. What you can't do is log ship it. No, you can mirror that one as well.
You can do both. You can do them all.
All SharePoint databases can be mirrored. That was under. Oh God, now you've got me.
This is now a chalk talk instead of a presentation. Keep the questions coming.
Yep. Yes. Yes. We were planning to do that, as to actually kick it over.
Yeah, that's the next step. So I'll do that while Wayne's digging out that information. So we've got a failover, we've got it configured. I'm going to go into SQL, locate the database. It's currently principal synchronized. In mirroring properties, I'm just going to initiate failover. And assuming we've got the rest of the permissions right, in terms of the permissions on the content DB specifically, this will fail over. This will revert to, once the log catches up, you can see this is now split to be in the mirror. So we're now principal on SQL 2. If I refresh this, that's now the principal. It's synchronized, which means the log's caught up. And if I go back to SPO3, where I had the page, not doing anything change, this will either throw a 404 or we're good. I guess, hands up, 404. the way it's going so far. Well, 403.
Okay, even better. So it's the accounts again.
It's the accounts.
That's the accounts. We didn't replicate the accounts. Sorry, just on the other point, it was actually on asynchronous mirroring and log shipping. It's all our support. The content DBs are supported except for the central admin content DB. On asynchronous and log shipping. Okay? So mirroring from a synchronous perspective, everything's supported. Okay?
Actually, the accounts look good on this one.
Okay. Should we move on? Or?
Yeah, we should move on.
Yep.
Okay.
Well,
Come at the end, I'll show you it working. We need to get through the content.
okay. Let's go slide. Correct. The only thing you do need to watch, though, is that if you've got different managed accounts for the web application, okay, so that's the other time that you need to do it. So you've really got to look at what accounts are actually going to be used based on the service application pool or based on the web application pool. Yeah, so that's why the reason we're getting the 403, because the web application pool hasn't been taken across to it. Okay.
But no one else gets 403. Okay. Okay.
Right, okay, so what we're going to look at now is kind of look at things that you can do from a SQL Server optimization perspective. So we're going to look at this thing called query statistics, another thing called max degree of parallelism, look at the TempDB, which was a question that we had out of the first session, and then look at pre-growing the databases. So we've got this thing called query statistics. So basically the way that SQL Server actually works behind the scenes is that if you've got a table out there and you run a query against that, come on, Lana. Okay. And you run a query against that. Basically what it does is it creates some stats behind the scenes. And I do apologise, the colouring's not too good there to see. So what you basically have is that it creates this histogram of saying, where does this information actually go and where does it actually work? Now the reason it does that is that, with SQL, what it's trying to do is that it's trying to make it easier for the query that runs, it goes back and uses this particular information to help actually optimize that particular result that comes back out. So that's what basically happens when we go through, we run a query against that, looks at the histogram table that we've actually got there, knows where to go and where to get the information back, and we're all away laughing. So that's pretty cool. The issue is, though, is that if you get, for example, some outdated stats, what can actually happen is that your histogram could actually be out of whack, which means that when you go to the query, you can actually get some misinformation out of there. So what it means is that on a regular basis, you should always be upgrading your stats, okay, both your auto-create and auto-update stats that you've got there. And this is standard SQL Server, DBA type administration where they go through and make sure that the stats are actually running. The bad news is, though, is that SharePoint doesn't actually like this. Okay? So the way that SharePoint works, when it goes out and accesses the databases, is it does some weird and wonderful things. And a lot of that has actually got to the way that the data is actually stored within SQL Server. So a good example of this is that we all know the content databases, that they store all the information for our list items. Within that database, we've got a list item table that's sitting there. Now, with a list item, we may actually have a list, but that list item may actually be spread over multiple rows within the database. Okay, now if you kind of think about that, that kind of makes sense because we can actually add in additional columns into that. So it's actually quite a dynamic way that the information gets stored in there. So we have a real long list item that can be in multiple rows within the select statement. So the relationship between how stuff looks in SharePoint doesn't actually relate to the way that stuff is physically stored within SQL Server. So the issue here is that SharePoint actually does its own optimizations behind the scenes. So what we've actually got to do is that we've actually got to turn off auto-create stats and auto-update stats as well on our content DBs. Okay? So the reason for doing this is that it seems a little bit counterintuitive, but it actually gives you better performance. So this is a bit of a discussion that if you've got your DBAs actually managing your farm or managing your databases, this is something you've got to ask them to turn off because a lot of the times they run their maintenance plans, put them back on, and then you start getting into some interesting performance issues with that. Anything else?
Yep.
Okay. Predominantly the content DBs. So there is a couple of KB articles out around this which actually tell you to do this. The other interesting thing too is that if you're creating your content DBs through the central admin or through PowerShell, the auto-update and auto-create stats are already turned off for you. Okay, so SharePoint knows about that and turns those off for you. However, if your DBAs are creating your databases for you, as we had the discussion in the previous session, they may not be doing this. So that's one of the things that you need to have your discussions with your DBAs. If they're creating the databases, make sure you turn this off. Okay.
Okay. Excuse me. So another feature that's quite commonly debated about with SQL Server and SharePoint specifically is this concept of the max degree of parallelism. So effectively, are we going to parallel execute our queries across multiple threads and multiple CPUs in order to ideally optimize the query and improve the speed? Now for traditional DBAs, we'll generally go down the idea of saying MAXDOP, maximum degree of parallelism, should be a high number, typically equal to the number of cores or number of CPUs that you have in the machine. SharePoint really doesn't like this kind of thing, and the reason being, there's a number of reasons. One is the SharePoint queries are not necessarily optimized for that type of execution, and overall, there's a significant number of executions or stored procedures within SharePoint that are specifically written to operate with a single parallel execution plan. You can look at them, you can find them quite simply if you actually look inside some of the stored procedures inside the database. Just
in a non-production environment.
Yeah. You will see SQL, or you'll see that the developers of the stored procedures have already added a MAXDOP query hint with a simple scenario that says use MAXDOP 1 or options 1. If you don't go down that route, if you think, okay, DBA is no better, they're going to go down and increase the MAXDOP value, set it to 4, 8, 16, whatever your number of CPUs might be, you'll start to experience some quite unusual behavior in SharePoint. Specifically, incremental crawls can take a hell of a long time to complete. Yeah. And if the whole search platform that I'm going to talk about tomorrow is based heavily on stored procedures and control of stored procedures, especially when the propagation process. And you can run into a nightmare scenario with incremental crawls in that situation. Yep. Other things, timeouts and
CXPACKET waits. So what exactly are CXPACKET waits? Basically what you can see then is that if you've got a query and it breaks into multiple threads, what you'll start seeing as part of the logging is that you'll see these packet waits as the threads kind of spin off and wait for the other processes to finish running. They start putting these CXPACKET waits out there in the event log, in the SQL Server logs. And if you start seeing a lot of those, then you know that your max degree of parallelism isn't working that well. So what that basically means from a SharePoint perspective, you've got to set it to 1. Now there's a bit of an issue around this, okay? Max degree of parallelism is actually a SQL Server instance setting, okay? So to repeat that, it is a SQL Server instance setting. So what that means is that you could actually have other databases in your instance which may not actually want this setting to actually be there. So what this kind of alludes to is that SharePoint databases should really be in their own SQL Server instance. Okay, and try and keep that as a rule of thumb, primarily because of this reason. Okay? Cool. So, the other thing, 0, which means as many threads as you've got as it can spawn off based on the number of CPUs. So the other thing to think about too is we've got this thing around the contention. So why have we got cards here? What's the deal with contention? A little bit lame. Okay. A little bit flat. Let's move on. Okay. So what we're going to need to do here is worry about the TempDB. Now the issue here is that the way that SQL Server stores its data, it stores it in what we call, obviously in pages. Now the thing about this is that when it goes to extend out a little bit more disk space that it actually requires, it allocates it in 8K chunks. So what that basically means is that it needs to get a little bit more, so to extend the log file or extend the database that it's got there, it allocates that in 8K chunks. But it actually requires, where it lays it out on the disk system, to actually have that as being continuous memory that you've actually got there. Okay, so continuous disk space. So what that can actually happen then is that when you go to extend it, if your disk subsystem that you're actually hitting for, which going back to the session we had in the previous one, isn't actually allocating that in 8K chunks, you could actually be using a little bit more space than you require, and so you're not actually providing the ability in your disk I/O subsystem to actually allocate it in 8K chunks every time. So what that basically means is that what you've got to do is actually have a look to see what's actually your allocation that's actually on the subsystem to make sure it is in 8K chunks, because that's the optimum that we've got there. So here's an example. So what I've got is that I've used my USB drive, gone out and just basically done a little bit of a, just run a check disk against it, and it's told me that it's been allocated in 32K. So this isn't optimal. So if I've got this from a TempDB perspective and I'm doing this in 32K chunks, it can't actually lay it out in an optimal manner. So I'm actually going to get a significant performance impact on doing this. It's probably also not a good idea to use a USB drive as a SQL drive either, okay? So that's really the point about it. So what we've got to basically do is that you need to go through and actually configure the TempDB by adding additional resources to it. So the general guideline, there's been a little bit of a debate around this, which is how many DBs do you actually add? So the general guideline here is quarter to half the number of data types based on the number of CPUs up to a total of about 8. So that's the general rule of thumb that you should be using on that. However, if you do see a lot of latch contentions, okay, increase the number of files that you're actually allocating, go through a retest to make sure it goes through. Now, some people also think that you need to do it on multiple transaction files. The recommendation here, once again, is just to have one transaction log, and so you should be away laughing with that. Okay, so how do you actually go through and do this? So how do you detect this contention? What we've got here is just a straightforward SQL query that you can run. Now this is available on TechNet, and this thing from TechNet is actually valid, okay, unlike some of the other content that's out there. So the key thing that we're looking for is basically running this query, bring back the PAGELATCH times. We run the query and we get that. Now is this good or bad? Having no results is actually a good thing. Okay, so that means we're not having match late, so we've actually got the optimal number of files, sorry, not files, of the number of CPUs that we've actually allocated against that, set up correctly. Now the only issue around this though is that we've got to be running this on a regular basis. So running this once and forgetting about it is not a good thing. This needs to be part of your regular maintenance and planning that you actually do on your databases. So that's good. You can talk about that.
So, sorry, Wayne. So the TempDB placement, I guess, similar to the general advice you get with placement of SQL Server databases, is try and go as fast as possible. It stands to reason. TempDB is going to get hammered by just about every single process that's running in SQL. Specifically, even more so if you start doing a lot of SharePoint search operations, a lot of backup operations, all those kind of things are going to make heavy use of TempDB. If you host it on slow disks, you're going to see your SQL Server Performance tank. Basically, you're going to have some real problems. So the recommendation is high-speed disks, RAID 10 if possible. And the key thing there is to pre-size it. The last thing you want to do, as Wayne mentioned about TempDB gaining more space, is you don't want TempDB constantly growing and growing and growing in tiny little chunks. Yes, we can configure auto-growth. Absolutely, in all databases you have auto-growth turned on. It's a catch-all scenario. But make sure if you can, size it appropriately and scale it out, or spread it across all those files that you're going to use for TempDB, all the same size initially, and spread across different set of disks, different set of spindles for each of those files.
So if I've got a 1 terabyte content DB,
don't ask me that question.
How big should my TempDB be?
It's on the slide. I can see it. 25%. Yeah. So as Wayne's leading me to, a 1 terabyte content DB will be a 250 gig.
Yeah.
Temp files.
So the key thing here is that you do have to look at how big your content DBs are, or how big they're expected to get, and do pre-grow your TempDB to that size. Okay. So the other thing too is that whether or not you actually set the auto growth. So the recommendation here is that you actually want to have it at a fixed size if it's smaller than 200 meg. Okay, so basically, if in our 1 terabyte size, we need a 250 gig TempDB, then in that case, we'd actually set the auto growth to actually keep on going without actually having fixed limits on it. Okay. Cool.
Okay, so a few other recommendations. We mentioned previously about auto-growing databases. We mentioned a few times. The other thing about auto-shrink, just as a kind of a hands up, does anyone in the room use auto-shrink on the SharePoint databases? Okay, gold stars. Fantastic. Okay, we don't want to do auto shrink for a number of reasons, but basically when we talk about database recommendations for auto grow, we always say, pre-allocate the file size. So if you're going to deploy your content DBs in 200 gigabyte content DB growth maximum, roll them out as 200 gigabyte files. Only enable auto growth for, in this case we mentioned catastrophic situations. Typically the last thing you want to happen is the database gets full and no one can add anything else to it. That's going to raise a whole pile of support calls, it's going to raise people getting frustrated. So by having auto growth configured, you will at least catch the scenario and be able to service the user requests. But at the same time, have it set to a fixed size. You don't want to be auto growing by tiny little chunks. Each auto growth stage takes resources. It's a slow down process. It will slow down the access to the database while it auto grows. So if you do have to auto grow, make it a significant amount of chunk of disk space. And from purely from a monitoring perspective, you also then want to be in a scenario where you're monitoring the size of those databases. You don't want to just leave auto grow to do its thing. Everyone's happy, we're growing the databases. No one's complaining about lack of space. Make sure you're monitoring the size of those databases. And if you reach a scenario where you are invoking auto grow, or even preferably before you get there, you want to be moving site collections out of that database and have a kind of a rebalancing approach where you'll deploy new databases, move site collections out of the old one, put them in the new one where you've got plenty of space to go at. From a shrink operation, shrinking a database is a bad idea. If you start shrinking your SharePoint content databases, in a very simple analogy, why shrink something that's only going to grow again? That's kind of one point about it. The other thing is, if you shrink the SharePoint databases and then do things like reorganize, reindex or rebuild the indexes, all you're going to do is just fragment the whole thing out again. So you're just going to get this yo-yoing situation where your databases are shrinking and growing and shrinking and growing. It leads to fragmentation. It leads to an awful performance in terms of SQL Server and the end user experience. The slide shows the kind of settings on the DB. Nice and simple. Enable and set the settings. Typically, how big would it be? It really depends. 200 gig database, you might decide, let's go for 200 meg or 500 meg perhaps as your auto growth catch-all situation. Like I say, hopefully, if you do have to invoke the auto growth, you'll catch it and never have to need it again. Kind of you should need it once. You? Me?
It's you.
Oh, great.
It's Lana again.
Okay, here we go. So we're just going to look at some of those properties.
Yep, I'll bring that up.
So this demo should be fairly straightforward. He says.
Oops.
So the first thing we do, we're going to look at, the first thing we mentioned when we talk about optimization was MAXDOP. So there's a number of ways to configure MAXDOP. The one that we're interested in is on, where is it?
Up on the properties, yep.
Where have I gone?
Advanced. It's advanced.
There,
and next degree of parallelism.
Okay, so we broke our own rule. We have the max degree of parallelism set to 0.
So is that good or bad? That's bad. Sorry, there's a question?
Can I ask a question about virtual SQL servers? Do you recommend lots of virtual CPUs or just one or two?
Okay, so that question kind of starts getting into what type of virtualization technology you're using. So I'll talk about my preferred one. So there is
Server 8.
Sorry?
Server 8, of course.
That's right. Sorry, there's also Server 8 as well, but it's still Hyper-V. Okay. So there is a couple of limits around how many CPUs you can actually give it. So a lot of it actually comes down to the socket, how many sockets you actually got on the host as well. So there is some guidelines around how many sockets you've got on the host versus how many virtuals you've got. So have I really got a recommendation on it? No. Just don't go over the maximum.
Some people say only have one or two, because otherwise SharePoint spends too much time looking, or SQL Server spends too much time looking at spare processes.
Well, it really comes down to your socket architecture. That's really the point. Okay, so if you've only, I'm not talking about the number of CPUs, I'm talking about the actual physical sockets that are on there. So if you've got a 2-socket machine, which has got 8 CPUs, then you should be all right to have, say, 4 on each one, or go up to 4 or 2. the biggest issue around virtualization is not so much around the CPU, it's actually more around what we call a NUMA boundary, which is how much memory you actually allocate out to the guest machine that you've got. So once again, this comes down to a low level, which is down to the sockets, and it's the way that the sockets actually communicate out to the RAM that the host machine has got. So essentially, if you've got a socket which actually goes across what we call a NUMA boundary, then you can actually get quite a significant performance hit. And that comes, but that's getting right down low with the subsystem level. Okay.
Okay. So the other setting we talked about, we talked about memory.
Yep.
So you've seen the configuration for MAXDOP there. If we look at the an option to look at is the memory configuration of SQL. Now, there's a number of ways to do it. We can look at it through, I haven't turned advanced on, so in the interest of speed, I'm going to look at it through here. We have settings here at default. So again, there's a question of what's your best practice with SQL Server. My personal, and Wayne, correct me if you're not happy with this. I always set if I'm looking at a physical box or a virtual box indeed with a single instance, I will always generally configure SQL Server to use minimum and maximum memory thresholds the same of the total amount of memory in the machine minus 4,
yep,
or minus 4 gig. So I'm leaving 4 gig for the OS,
yep,
and I'm leaving, if it's a 32 gig box, I'm leaving 28 for SQL. And yep, if you have multiple instances, just divisions of there. In this case, I'll leave it by default for now, but yep, in this case, we've got a two instance machine, or 2 instances running on one SQL Server with, I think, 12 gig of RAM in these boxes. So we'd set it for 16 gig of RAM, sorry.
Yep.
So we'd set it for minus 4 is 12, divide by 2, 6. So we'd set it 6 gig each. You might decide to change that slightly depending on what the load of SQL is and what its actual purpose is. But typically, I'd say best practice or common good practice is to configure it for the, split the memory equally between the 2 instances.
SQL Server loves memory. It's a bit like Parkinson's law, or was it Peterson's law? I think it's Parkinson's law. It will always expand to the amount available. So.
Okay. Well, you did TempDBs earlier.
Yeah, yep, so that's all fine. Okay.
Okay, so kind of the next thing we're going to look at is a few little bits and pieces. I mean, there's obviously there's lots more things around SQL optimization, just memory and MAXDOP. But a couple of things we're going to look at is defragmentation, so index defragmentation specifically. Stats update, when we did a good example of updating statistics earlier and how that works. Then 2 other things, maintenance planning and monitor blocking, or monitoring your blocking. Maintenance planning is critical to the performance of your SQL Server. Getting the maintenance right is probably the single most critical thing you can do among most of the things we've seen already to ensure that your SQL servers are operating smoothly and effectively for your end users. So one of the things, the first thing we want to look at is the concept of tuning or index fragmentation. So this diagram actually is a really good example. So you can imagine a scenario. SharePoint is specifically prone to fragmentation in the databases, generally because most of our indexes are built on hideous GUIDs, which is a nightmare thing to build an index on, as I'm sure you can imagine. So we get with a situation where constantly inserts and deletes and updates, the database gets fragmented like crazy. You can't really insert records in the right order when you're trying to insert into a GUID-based index. It just isn't possible. So we end up with this hideous fragmentation process. So you imagine a scenario here of SharePoint after a certain amount of time. We're going to do a single query. We first of all start and hit the index, and we hit the SQL file or the index at point 1. The next read goes to point 2, and then you follow the arrow around. Now that read process is horrendous to actually just bring back some data. Multiply that by thousands of times, and you get the experience of a badly fragmented SQL Server database with SharePoint. Effectively, your read ahead, you optimize the read ahead is just broken. So by defragmenting the index, or by reorganizing or rebuilding the index, we can solve these issues. Simply by keeping it regular and make sure that the index is nice and or defragmented or nice and contiguous. How can we detect index fragmentation? Fairly straightforward. There's a query you can use, and you can see the output there that we get for each of the individual databases that we have. we can see a percentage fragmentation level. I don't know if you have a best practice that you think is how fragmented you'd allow it to get?
No, I don't.
I think if you read some of the, Bill Baer wrote a paper a few years back now on optimizing SQL Server for SharePoint, and his recommendation was if your databases are more than 30% fragmented, or your fragmentation exceeds 70%, you want to rebuild the index. If it's anything less than that, up to 5%, just reorg the index. And that might depend. The SQL DBA might give you a completely different story on that. But typically with SharePoint, those are kind of guidance that's been out for a number of years now. We have a health job. We're inside SharePoint to detect and actually fix this thing. So with the two health jobs that we have running here, basically if SharePoint automatically detects that the database is fragmented, or specifically the indexes are fragmented, we will auto-fix that situation. And you can choose to auto-fix the situation based on a fragmentation of greater than 30%, but only on certain databases and only if the row count or the number of objects in that database exceeds a certain value. Yeah. So 10,000 items, you'll easily hit that even in a small SharePoint database.
You can do that one.
Okay.
You're doing well.
So DBCC CheckDB. Does anyone run this regular on SharePoint databases?
Whoa.
Okay. With or without repair?
You're not going to fess up now.
Okay. So DBCC CheckDB is probably one of the most, intensive operations you can do on practically any database. With SharePoint databases, we have some quite clear guidance around what you can and cannot do. DBCC CheckDB, if you think of it very simply, it's like a bit like checking a disk for errors. It can detect both physical errors, so I can't even read this value, or the actual file itself is broken, or it can also detect logical errors. So when it can't read, so for example, and a specific example I had just last week with a SharePoint crawl DB, where we had run DBCC CheckDB. It threw an error. It told us we had a logical data error inside the anchor text table. What do you do with that? It's unsupported to run DBCC CheckDB repair all with data loss on a SharePoint database. So we're in a bad situation.
So the answer is restore.
The answer is it's a search DB, so we just blew the data away. That's another thing. Typically you'd restore. In that scenario with the crawl DB, we just created a new crawl DB, ported all the content sources over to that new DB, and then we let the old DB die when we finished porting everything over. But it gave us a problem. And because those operations are not supported on SharePoint databases, data recovery is very difficult. So the thing to think about specifically is maintenance planning. So make sure that you've got the right maintenance operations in place, using the right options within those maintenance operations, making sure that the frequency of execution is correct. So you don't want to be running index rebuild every few hours. That's just asking for trouble performance-wise. And it's probably not necessary. Think about the amount of churn. Content databases are churned constantly. We mentioned already about the fragmentation that can occur. So you're going to frequently get updates. Lots of read, write, update, delete operations in a content DB leads to lots of fragmentation. So your content DBs, you might want to do updates on a slightly more regular schedule.
Yeah, we're running out of time too, so.
Okay, so we just do this.
Yeah.
Okay. So think about creating the plans. There's a number of ways to do it. There's manual operations ways to do it. There's a number of ways documented on both SharePoint documentation on TechNet, certainly SQL Server documentation in terms of creating maintenance plans. A very, very simple way to do it is through the wizard, which I'll come to if we have any time at all at the end. I'll show you creating a maintenance plan through the wizard.
We are up with time.
We're up with time. Okay. Yep. Shame. Okay, so I'm going to flip them. This last bit then is monitoring for blocking. So there's a really, really good article now by Tony Rogerson, who's a SQL Server MVP and runs the SQL Server user group in the UK. And he's written this article that talks about monitoring for blocking and how to detect blocking in SQL Server. And one of the key things to know about blocking is, as the description simply says there, If you've got more than one connection to an object in SQL, an object being an item, or a row, a table, whatever it may be, if you get one item that's waiting on the execution of another one to finish, you end up with this queuing situation where more than one item is trying to do the same operation or waiting for a resource. That causes blocking. Blocking is a nightmare situation for performance. It generates slow page loads, generates timeouts, and leads ultimately to a really poor user experience. Typical, just to give one very, very quick example, we had a user who loaded a content editor web part that loaded itself, okay? Pointed to itself. The amount of blocking that generates is incredible. You want to see SQL Server fall over? That'll show you blocking. So we can detect it using event notifications. I can give you the script and point you to Tony's blog. He's written a really, really cool article on this, and I can show you offline how this works, actually. But we need to get moving. Well, basically, ways to deal with it: reduce fragmentation, judicial use of indexes. So be very careful about how you place your data and using the indexes. Don't try and change indexes that SharePoint gives you. Yeah. Adhere to the boundaries and be realistic about the database schema. The SharePoint database schema is not perfect, as we all know. It is what it is, and it is what it is because of the way SharePoint workloads operate. There's not a lot we can do about it, certainly for the foreseeable future. So I'm not going to demo this. If anyone wants to see it, you have to come and see me after. I'm here all week, or for the rest of the session, so we can show you this running. I'll point you to the blog. It's a very, very effective way of detecting blocking, reporting on the blocking even, to tell you where the blocking is coming from, which process, which host, etc. So apologies for not being able to do those demos. Summary, and if we're out of time, I guess we take questions offline while the next session sets up.
Thank you.
Okay, so sorry for the speed up at the end.